for Business Unit Cloud and IP at Ericsson. Howard joined Ericsson in 2014, and he has a long-standing career in technology, having rich experience in hardware manufacturing and software services in countries such as China, Canada, US, and Sweden. So ladies and gentlemen, without further ado, I will now turn the program over to Howard.
Good afternoon, ladies and gentlemen. Very happy for all of you to be here and very excited to be invited to this event. Computex is one of the key global events for sure. And on a personal side, you know, my grandparents used to live just down the street, so coming home to Taiwan is always nice. And the topic for my talk today is really around next generation human-machine interaction through IoT. And I apologize for the long title. But I think too often than not, all of us in technology, we always take a look at specific technologies. Is it lower latency? Is it a faster CPU? Does it save battery life? What does it do for me? And we often forget, why are we trying to get here in the first place? So really this next 20-25 minutes, I'm going to present more on a macro view of what is IoT, what are we actually trying to accomplish, and how is it actually going to impact all of our lives? Now, keep in mind, that's just my personal opinion. So take it with a grain of salt. But before we begin, let me quickly introduce Ericsson. Ericsson started in 1876. So this year really marks our 140th year anniversary. It was started by our founder, Lars Magnus Ericsson, together with his wife, in their garage. So it sounds like a very similar startup story we see in Silicon Valley these days. Now, 140 years later, what has Ericsson evolved into? Today, our core business is in product side with radio base stations selling into telecom service providers. And we also have a huge global services business that spans our business across 180 countries globally with about 120,000 people in the company. And that puts us in about the top 500 global Fortune 500 range. Revenue-wise, we do about $35 billion a year, and I apologize, this is in Swedish kroner. But a couple of key points that I want to point out, and I think most people probably don't realize. One of them is actually in today's, if you're using a cell phone, let me see how many of you have a cell phone in the room. I'm going to assume it's everybody. And you're probably running through an Ericsson backend infrastructure without realizing it, because we sell to the telecoms directly. And under those, there's about 2.5 billion global subscribers that's running through our backend infrastructure. And of that 2.5 billion, we actually directly manage over 1 billion users. So what does that mean? That means we actually not only provide just the products, but also the services and the fully managed experience for over 1 billion subscribers in the world today. Now, I'd like to dial a little bit back in time to the age of cavemen. And I'm going to use a couple of cavemen analogies, so I apologize in advance if you're offended by cavemen stories. But why did humans create machines to begin with? I think humans, since the days of caveman, we have been using tools. We've been using a lot of tools, mechanical tools, tools to help us hunt better, tools to help us start a fire. And over the years, the number of tools we've expanded certainly helped our lives and everything. And if you really think about why we created tools and why we created machines and why we created computers and everything else, you have to root back to the human brain itself. Now, my brother is a neurosurgeon, so he and I often have discussions, well, neurosurgeon is a fancy word for brain doctor. And we always talk about, you know, from a technology and product side and what he does, what are the overlaps in those things? So if you think about what your brain does, it actually does basically 3 functions. So it allows you to communicate with other people, call it networking. Allows you to retain some memory of things you've learned, We call that data storage. And it allows you to solve problems. We call that compute. Right? So actually, we created machines to really take over a lot of the functions we see in the human brain. Now, why did we do that? Now, if you think of the brain as a product, and then, of course, you have hardware, and then you have some software. At the kernel layer of our brain, there's two fundamental characteristics. Number one is the brain is selfish. Okay? So the brain will literally cut off blood flow to every other organ before it finally shuts itself down. So that's why when you say you're brain dead, you're really dead, right? And so by that note, we know the brain is selfish. On the other hand, it's selfish, but it's also lazy. It doesn't want to consume too many resources, too much energy. It's looking for the best ROI. It's looking to do more with less. So that also explains our human nature of being both, I guess, selfish and lazy. And that really is what's pushing us to create machines to take over functions that mirrors our brain, so we could do less. And out of that interaction, really, and I guess you've seen other slides by Martin that says, it's going to be 50 billion devices by 2020. I think the future really says it's somewhere between, let's say, 28 and 50. But we know it's a big number. Okay, so how do we handle all of these connections? And another thing is, as these machines come online in an IoT context, I think one of the things that we also need to recognize as part of the human race is that also, going back to my caveman analogy, in the days of caveman, we were the major contributor of data on planet Earth. Meaning, if you were a caveman, you were drawing things in your cave of you hunting an animal, you're creating data. We've been driving and doing these data for tens of thousands of years. And now we literally created a new citizen class on planet Earth that didn't exist before. That's called smart devices, connected devices, the coming IoT. So what's going to happen in the next 2 years is we would have created a second-class citizen that actually will generate more data than all of the human race combined in the next 2 years. And even by our estimation, in the next 5 years, if you think about the 13 billion number, that's a human as an end user. The 15 billion devices, that's a machine as an end user. And I'll have a nice architecture slide later, so to satisfy all the engineers in the room. But those are things we really have to think about in a human context, is that how do we deal with these types of connections? And I'm sure everybody has heard about this, seen this, knows about this, but I'll quickly go through it. If we really think about, and I said earlier, in the first, 4,000 or 5,000 years of human, we've been using mechanical things. It really wasn't until the electronics came on board that we started using things we call computers. And if we think about the computing era and the human relationship to compute, you could largely classify into these three categories. So the first phase is what I would call the mainframe era. Now, mainframe started, I guess, after World War II. And really at one point, and that was, compute was super expensive. So everybody had to put their money together to buy a big compute unit, we call the mainframe, and everybody had to share those compute resources. Out of that era, a very successful system company emerged, we all know, called IBM. Because IBM at one point, I believe, employed about 80% of American engineers after the war. So it had huge resources, huge efforts into building these big mainframe computers. Then 1980 to 2010, we could say that's the PC era. And Taiwan has certainly played a huge role in pushing that into our daily lives. So really in from 80 to 2010, we were getting more intimate with our computers. We were getting more of a one-on-one relationship rather than I have to share my computer with the guy next door relationship. And what does that mean? That means in the 80s, then you remember floppy disks, right? You carry around floppy and carry around data because, data was about this big and compute was expensive. So you carry data around. And then through the 30 years, as we get into cloud, we clearly see now data is huge. Data is massive. The cost of compute went like this. So even our relationship and how we use infrastructure has fundamentally changed. It used to be cheaper to carry data. Now it's cheaper to move compute resources. So how do you manage that in a whole new era? And one thing we did in the PC era was we actually managed to kill all the system companies. So IBM, Sun, all of these traditional system companies, and let's think of system companies the way let's just qualify that term. For me, a system company is a company that does, basically think of ASIC or hardware components all the way to the application layer, right? Full stack delivery solution providers, those type of companies. And because in the PC era, the mantra was do one thing well. Do one thing well and focus on that and make that your core business. So we fundamentally changed everything, and we slice and dice the entire vertical into many different layers, right? And Taiwan certainly plays a key role in that full vertical. Then we come to, let's say 2010, I put a question mark behind 2040 because we don't really know. It's the future. So we're thinking the next 30 years really should be the cloud. And what does the cloud mean? The cloud means we've actually completely reversed our relationship from the mainframe era. Mainframe was super expensive compute, lots of humans trying to take turns using it. Then we went one-on-one with our computer relationship. And now a single sysadmin or anybody who needs to manage a data center, a large-scale data center, can't do it through the internet, right? Through a connection. You now have and that's why we've seen this explosion of startups, and certainly our friends here at Amazon Web Services also can attest to that. We've lowered the barrier significantly to access of technology. You used to have to raise a lot of money just to build infrastructure so you can post a picture of your cat. Now all of that is readily available at a very low cost that actually tracks Moore's Law. So our whole relationship with machines, and in particular with compute, has completely changed into the cloud. So another thing that the human brain does, and that sort of separates us, is that we're able to network to other humans, and we learn. We learn, and we store data. We call it knowledge. And out of that data, we think. And our thinking capability provides us some kind of insight into the future, or we take guesstimates into the future. Important questions, like what am I going to eat for dinner tonight? So one thing we do know out of all of this past historical references is that we know the inevitable is coming. And we know IoT is coming. Everybody in this room knows that it's happening. Otherwise, you wouldn't be here. And what does IoT really mean? It really means at a certain time and point in history, certain technologies emerge and creates a new reality in the way we live and work. I'll reference back to the emergence of the smartphone. And I think if all of you remember about 99 or 2000, we all knew smartphone was coming. A lot of hardware phone vendors were trying to build smartphone-like devices. But then it never happened. It never happened until two other things happened. One thing was 3G happened. When 3G happened, that increased our speed in using our phone devices. Then another thing happened. Apple. Apple figured out the business model. We were all building technologies without a direction and without a clear concept in mind in where's the money. Apple really made application consumption extremely easy. And it changed the way we consume both music and applications. And that changed the entire smartphone industry. That made smartphone come alive. So for the IoT, we have these three technologies coming together. We have a lot of machines getting some memory and a Wi-Fi chip or something. And you guys all, especially in Taiwan, I'm walking around Computex, it's like, yeah, my coffee maker's now online. You saw the other slide from Vincent. My belt is online. I don't know, does it help me lose some weight? Real-time measurement. So one thing is you have everything you could possibly think of getting connected. The other thing is you'll think about a lot, which is this massive amount of data. Data is everywhere. The fact that all of our cars, an average BMW these days has about 80 to 90 sensors. So are you still driving a car that is mechanical, or are you driving a big fancy phone? You decide. The other thing, which is somewhat related to Ericsson, is that we know 5G is coming. And 5G will actually completely change the infrastructure. And I'll talk about that a little bit more. So we know all of these things are coming together in the next 3 to 5 years. And we know all of this is getting put into one big pot. What we don't know is we still don't know the business model. We don't know if it's going to be Apple or somebody else, but we know somebody's going to make a lot of money. We just don't know who it is. But we're all doing our little part in trying to figure out, from Ericsson perspective, we're trying to make 5G happen, right? I'm sure everybody in Taiwan is trying to make connected devices go as fast as possible, and hopefully everybody buys it. And if you talk to any American companies, they're talking about, how do I use software to do analytics and manage data and all of this? So this is really it's a global effort, and we're all working on our specific areas, but we don't know who's going to win. That's the only question. So what are the key challenges? Let's bring it back to the technology level. We know you're going to have massive amount of connections. Pick your favorite number between 28 billion and 50 billion, right? We know there's going to be a lot of diverse use case requirements. I'll use my own household as an example. I'm a regular family. Me and my family, we live in Sweden. So as you heard from Martin, we don't use cash. I can't remember the last time I used cash. And actually, I've had a weird experience where I actually walk into a Swedish bank with Swedish money, and I asked them to deposit it, and they said, no, we don't take cash. So, different world. So in my house, between my 2 kids, my wife and I, we have 23 connected devices. 23. And I can guarantee you it's a very diverse use case. Between my kids playing Minecraft and me using it for work. And if you even think about your own family as an ecosystem, the different verticals you actually engage every day, right? That's really the problems. That's a miniature of the problem, universal problem we're trying to solve. And then last but not least, everybody wants what? Lower cost, longer battery life, and we want wider coverage. That's like asking for justice, peace, and beauty. Who doesn't want that? So how do we solve some of this? Well, this is the architecture slide for all you architects in the room. You're welcome. This really is the slide for our new world infrastructure. So the key points I want you guys to focus on is the top left. Top left that is a human as an end user. So you think about everything we do to the web today. It's all reading and writing. That's all we're doing. We need a connection so we can read and write onto the web. And how are we engaging that? So everything, the human activity on the web is a mixture of voice media messaging. Everything you could think of. Facebook, Flickr, showing my age, sorry. Instagram, Snapchat. All of that, Twitter, is a mixture of just voice media messaging and the human as an end user. So a human as an end user, what does that mean? That means massive download. That's why we need to go from 1G to 2G to 3G to 4G, because we want everything and we want it now, right? Now on the bottom left, that whole machine-looking icon things, that's the end user as a machine. So what does the end user as a machine look like compared to the end user as a human? The end user as a machine, I can tell you, requires massive uploads. Okay? And another thing that's interesting is, thank God machines are logical, so they use less adjectives than humans, than when we communicate. When you and I talk, I use a lot of adjectives to describe things. Machine languages can be simple, short, asynchronous, event-driven, something like, so even the programming language has to change to maybe something like Node.js, which is, server-side JavaScript, which is asynchronous, event-driven, lightweight types of code. So in this world, the most important thing is control systems. So how do the machines actually communicate to each other? How do they communicate not just through a centrally located data center, but really on the edge? And I think this is, and I said, cloud is really a 30-year journey for all of us. And if you remember correctly, usually the first 10 years of any start of a new architectural journey is starting by standardizing on hardware infrastructure. I mean, we really, in the PC era, until basically x86-1, we couldn't start moving networking onto the web, we couldn't start moving storage, and then also ultimately compute. And when that process was complete, then we move into the cloud. So in that world, a lot of this is machine learning, and how do we do? Of course, being Ericsson, we have a big access thing, right? And of course, I'll explain the rest of the slide very quickly. If you think about our core customers, which are the global telecom service providers, they have data centers and they have central offices, they have, call it regional data centers. None of them call it the same thing, but we know they have a lot of sites. Let's just call it sites. And all of these workloads either go into a public cloud, like Amazon, or they stay certain data into their private data center. And the mixture of using all of this to optimize the cost layer is what we call hybrid. So what does that mean to you and me in real life? I'd like to use an example, and I'll use the connected car as an example. Number one, because I'm a car guy. And number two is my talk, so I get to choose which vertical I want to talk about. And the reason I like to use the connected vehicle cloud actually is really, if you think about me, I'm a human. And me as an end user, I probably generate most data in 3 places. My workplace, my home, probably namely around my kitchen, and then in my car. Okay, so as a human end user, these are the places you actually generate data. Now, I use a car example because today we talk about smart cars, and we talk about smart cities, and we talk about smart cars all the time, actually. But if you really think about today's car, it's not really yet smart for me. Smart car today does what? There's probably a 3G connection, and it probably downloads some maps, and it downloads some apps. So you could consume music when you're driving, and you can know where you're going. But that's not really autonomous yet. A smart car, for me, has to do 2 other things. Number one, it has to be able to talk to other cars without a human intervention. So how does my car talk to all the other cars driving around Taipei, for example? Another thing the car has to do is it has to be able to make decisions. If it's always a human making a decision, that's not really smart. We think of smart people as the ones who can make decisions for themselves. Isn't that the whole point of education? Is that we can make decisions for ourselves. So when can my car start making decisions for him or herself? And that, what does that require? That, in my mind, really requires pushing compute all the way out to the edge. Why? Because of latency concerns. If I'm stuck on traffic here, and I expect my car to say, okay, I'm going to reroute myself, it can't go back onto a far out data center and then come back. That's not real time enough. It has to sit on the edge. So together with 5G, we make that happen. And that, to me, is more of the smart car evolution. And this is going to completely change. And I think, we're in the era where, like I said earlier, everybody's going to put memory and connectivity into every device you can think of. The next 5 years is going to be a long list of filtering. Because there are going to be things that we just find just doesn't make any sense to make them smart. But then there are going to be things that are extremely useful. So I really see car as one of those home devices that you really want connectivity and you want to do it in a good way. And this is sort of a slide that just talks about the potential business model. Now, we're not saying this is it, but look at the life cycle management of your car. This is the life cycle management of your car. So how do you consume everything as a service? You have to start consuming everything at a life cycle perspective. So really my conclusion is we are all here. Thank you for coming for the talk. We really stand at an important time in human history because our machines or our tools never talk to each other. In the next 3 to 5 years, our tools or smart machines and connectivities and devices, things, they're going to start talking to each other. And they're going to start making decisions around what to do, what to read, what to write. And that'll have a profound impact to our human life on planet Earth as we know. And I'm really looking forward to, meeting all of you. If you see me in the corridor, feel free to grab me. Love to say hi if you have some thoughts to share. But I think it's really an exciting time for all of us as a human race. And I really look forward to more engagement with you, all of you here at Computex. And thank you for your time. Again, my name is Howard. Thanks.
Thank you, Howard, for joining us this afternoon. And ladies and gentlemen, we will now take a brief break. We'll break for about 10 minutes. The time now is about 3:15, so the program will resume at 3:25. 我们现在进行中场休息时间，现在的时间大概是3:15，我们休息10分钟，请各位贵宾于3:25再次的回到现场。